Okay, so we're ready to do our math now, finally. Here we go. This is review number 2, and we are going to start with problem number 18. Next is a sketch. So here we go. All right, so it's an exponential function. Now I want you to be real careful though. The base of the exponent is 1/2. That is a number less than 1. So what does that mean in terms of exponential growth and decay? It's a decay problem. So that means instead of having the normal exponential picture, it is going to be reversed. Now, if it makes sense to you that it's decay, so it looks like that, great. That's good enough. If you need more convincing, remember that 1/2 is 2 to the negative first. And when you change the sign on the x, so 1/2 to the x is 2 to the negative x. And when you change the sign on x, what do you do to your picture? Reflect it. So that's why we have a decay. Now, that's this. That's this. What does that do? -1 on the x. What does that do? Doesn't lower it. It takes it to the right 1 unit. So the point 0, 1 is now going to be over here, right? Everything is getting moved over. Asymptote's not changing. We still have an asymptote here. And that point, instead of having the point 0, 1, we now have the point 1, 1 on our graph. This was the original, so I'll dash it in there. Now, let's suppose you are hopelessly confused by that question. Set up a T-chart and plot some points. Connect the dots and you'll get your picture. Okay? So you don't have to do anything tricky. All right, now I'm looking on page 347 at number 94. I ran out of room and couldn't write any more problems, so I just got lazy and said, look in your book. So 347, number 94. Says the population of deer after T years in the state park is given by this equation. Yep, the equation is given. There's the equation. It gives the number of deer. So this is the number of deer. And this is the number of years. Tells me that. You can all read. Nothing hard about that. What was the initial population of deer? No! No! You cannot look at a logistic equation and tell me the initial population. What does initial population mean? The population when? When T is 0. Initial, beginning, after no years, right? So you have to plug in 0. To find the population, you have to plug in 0. You cannot, so won't that be 0? If I plug in 0, won't I have e to the 0th? And what's e to the 0th? 1. So my denominator is really just 100. So the initial population of deer is 12. We started with 12 deer. In order to find the initial value of a logistic function or an exponential function, it doesn't matter. In order to find the initial value, let x or t be 0. It's the y-intercept. Okay? Jack, can we look at a logistic function and tell the initial value? No, we have to figure it out. We have to figure it out. All right, second, when will there be 1,000 deer? What will I do? Same equation, when will there be 1,000? Plug 1,000 in right here. So I have 1,000 equals 1,200 over 1 plus 99 e to the negative 0.4. All right, how do I solve that? Cross multiply and distribute. So I have 1,000 plus 99,000 e to the negative 0.4 t equals 12,000, or 12, is that 1,200?
1,200.
Now what? Subtract 1,000. So 99000 e to the negative 0.4 t equals 200. Divide by 99,000. So e to the negative 0.4 t is 2 over 990. Uh-oh. Where's my variable? In the exponent, which means I will log both sides. And since the problem has an e in it, I will probably ln. Now, can I get the right answer if I log? Absolutely. It's just easier for me to do ln. Do you have a class or something?
I don't.
Okay. All right, so I'm going to ln both sides. And what happens when I have an ln and an e back to back? They're gone. So negative 0.4 t equals ln 2 over 990. So what do I need to do? Type something in on my calculator now. What would you suggest? ln 2 divided by 990, and then divide that by negative 0.4. So that comes out to be about 15 and a half, was that years? So about 15 and a half years. We'll have 1,000 deer in the park. What is the maximum number of deer? That one you can look at your equation and tell, because this number up here in a logistic function is the top asymptote. Remember, a logistic function has two asymptotes? This number is the top one. It's called the limit to growth. So how many population, or how many deer can this park sustain? A maximum of 1,200. After that, they just start dying from various reasons. Okay, and then number 20, same page, but number 89. Again, they give you a formula to use, so you don't need to worry about that. Number 89. Okay, so this gives me the light intensity at a depth of x feet. This gives me the light intensity at a depth of x feet. So what does the problem want to know? Find the intensity at a depth of, so what am I going to do? Plug 25 in for x. You cannot be confused by that. You can read. Just plug in what they tell you. Was it 25?
Yeah.
So I'm going to figure out what that is. Okay, now I have kind of a different issue than I had before. I got to get rid of this logarithm. Over here, I actually put them in order to solve for that exponent. But now I got to figure out what that guy is, so I got to get rid of this logarithm. How do I do that?
Can't you separate them to log I minus log 12?
You can, but you're still going to have log I. So yes, that would be absolutely okay, but ultimately it's not going to fix your problem because you're still going to have log I. I need to get rid of that logarithm. It will separate. That would be a strategy, but you're going to have to do what I need to do anyway. How do I get rid of it? Clara?
Would you do 10 to the negative?
Absolutely would. Thank you, Clara. I love you. The base of log is 10. You rewrite this. You can't process it with the logarithm. So it's 10 to the negative 0.3125 power equals I over 12. That's how you get rid of logarithms. You rewrite them as exponents. 10 to the power equals I over 12. That I can type in on my calculator. Right? Times by 12. So my answer is about 5.84. Is that okay? So review 2. Oh wait, there's one more. Sorry, 21. If your credit card balance is 1234 and the interest rate is 18.49%, what must your monthly payment be to pay it off in 4 years? All right, they did not give you a formula, so that means you're on your own, right? You've got 4 choices. Is it going to be one of your memorized ones or one of the ones that will be given to you? It'll be one that's given to you. And what is the one word in the problem that tells me? Payment. If I am making a payment, I'm either using my FV or my PV formulas, and those are given to you. So I didn't put them on this paper, but they're on review sheet, the front review sheet. So, but I'll write down the one we need here in a minute, straight from the sheet. They'll be given to you on the test. But you're still going to have to decide, do I want the PV or the FV? Both of them involve making payments. How do you decide if you want the PV or the FV? How do we decide? What's PV stand for? Present value. What does FV stand for? Future value. So when I make payments, there are 2 ways that I can make payments, 2 reasons I would be making payments. One reason that I would make a payment is to save for the future. So like every paycheck, I make a payment into my retirement account, right? Or when I was younger, every paycheck I would make a payment into the kids' college fund, right? Saving for the future value. What's the other reason I make payments? To pay something off. My house payments, car payments, credit card payments, which are so stupid. Don't ever get in the position of having credit card payments. But a lot of people have them. They have to be paid off because the present value of the loan is, in this case, $1,234. $1,234 is the present value of my loan, and I'm going to pay it off. So if I am paying something off, I'm using PV, and the PV formula, which will be given to you, is this. Alright, there it is. There's the PV formula. So what am I plugging in here in order to answer question 21 on review sheet 2? What am I plugging in?
The present value.
The present value of the loan is 1234. Where do I plug in for the interest rate? These 2 formulas, the FV and PV, handle interest rate a little differently. What do I put in there? 0.1899 or 0.1849. You guys still haven't watched the video and taken notes. Okay, this truly, I hate to sound unladylike, but this sucks. At this point, we still haven't practiced. How could you turn in homework with these problems and not not know what to do. You copy the problems. Okay. I'm not doing it. I'm not doing it. So we'll find something else to work on. I'm not finishing this problem. You're on your own. You're on your own. So now that was review sheet 2. All right, that's done. What are we going to next? We can go to practice test. We can go to review sheet 1. I don't care. What have we not done? It doesn't matter. You have to do it all. So if no one has a preference, let's just do practice test 2. Practice test 2. Problem number 1, these are all no calculator problems. So we're on practice test 2. Look at problem number 1A. What is the answer? 25. No work necessary. That's a property. I don't even know what work you would do. It's a property. It's just 25. All right, what about B? -4. Same thing. We've talked about, we run into all the time, a situation where we have LNE. When they're back to back, they cancel, so the answer is just -4. C is going to require a little bit more work. How are you going to approach C? You're going to do it just like you did here. You have a logarithm that you have to get rid of. It's exactly the same as this problem right here. So you're going to write it x to the 1/4 equals 3. And then what will you need to do to solve for x? Well, you don't 4th root it. This is the 4th root. This means the 4th root of x. So how do we get rid of the 4th root, basically? So you're going to raise both sides to the 4th power. So x will equal 81. All right, D. Kind of a similar problem, but it has something additional that needs to be dealt with. Yeah, that 3 at the beginning has to be dealt with one way or another. My favorite way to deal with it is just get rid of it. I don't really want it hanging around. And you're always able to divide, as long as you have a number over here, you're going to always be able to divide. So just get rid of it. Now the problem looks just like these last couple we've done here. So you'll rewrite it as 6 to the 1st equals x plus 5. So x equals 1. All right, what about E?
You want, now it doesn't matter if you have like 121 to the, whatever.
Well, it really does, but it depends kind of how you're going to start the problem. But as long as you have a logarithm in the problem, you do not want a radical present. So if you choose to leave the radical in the problem, which is perfectly okay, it's perfectly okay to leave this logarithm because 11 and 121 have a very special relationship, right? So if you think of the problem as this, that these are going to cancel and the answer is just 2/5. Now, you don't have to do it that way though. You could go right back to the beginning and do what we've been doing and say 11 to the x equals the 5th root of 121. But even at this point, you don't have a calculator. So you've got to have both of these be 11s. So you'll think of this as 121 to the 1/5, and then think of it as 11 squared to the 1/5, and then x equals 2/5. So it's two different strategies, but you're really doing the same thing both times, right? That problem is not doable without a calculator if we don't have a special relationship between 11 and 121. If this had been a 13, I would need a calculator to do the problem. Alright, so that was E, so now we're going to F. Now, the issue with F is what?
You have to make the ln like one ln on each side.
Yeah, you got way too many logarithms floating around.
So could it be ln?
So you're gonna put these two together and make ln something. You're gonna put these two together and make ln something. They have to be put together.
What is it? ln 75.
It's 40.
Or it'll be 45. You're gonna multiply 15 times 3, and we multiply because they're added. Over here, it's going to be ln x over 4, because that's a subtraction, so it goes together as a division.
Do ln's cancel?
Yeah, this is a different situation than we had with some of our other ones. In our other ones, we had something like, the log base 8 of x equals 3. So we had to translate that. 8 cubed equals x. Here, you have a logarithm on both sides, so you're allowed to drop them out. So 45 equals x over 4, and x equals 180. We kind of have the same thing going on in G. Except it's only on one side that we have the issue.
Should you put one on the other side?
I wouldn't with the 1 there, it's going to make it harder.
Okay.
Because you can't combine the 1 and the logarithm, but you can combine the 2 logarithms. So I would leave them where they are, but they do have to be combined into 1 logarithm. And when they are combined, they will be combined how? Division. So it'll be x plus 2 over 3. Now what? We've done it about 10 times today so far. 11 to the first equals x plus 2 over 3. So 33 equals x plus 2, and x equals 31. H is another one that you probably, some of you anyway, don't even need to show any work for. Now I don't have the ln and the e back to back because the stupid radical's in the way. So let's get rid of the radical. What would a 5th root be? What would a 5th root be? 1/5 power. So this is e to the 9/5. So ln e to the 9/5 is just 9/5. Right. Alright, now switching gears, 2 says write the equation of an exponential function containing these 2 points.
So y equals 8 times 2.
That's how you want to start. That is right, Brenton. You want to start by thinking, okay, what's my objective? Y equals a times b to the x. Just like when somebody says, do you write the equation of a line? Y equals mx plus b pops into your head. Well, when you write the equation of an exponential, y equals a times b to the x pops into your head. So how do we go about finding the a and the b? We plug in the point that has a 0. This is going to be your initial value. So when you plug it in, y and x, plug in y and x, that is just 1. So 1/2 is a. We have observed that before. That's your initial value. So now your equation is y equals 1/2 b to the x. So what do we do now? Plug in the other point. So 8/9 equals 1/2 b to the negative second.
So it wouldn't be 1 over b squared.
So you can I probably, before I did that, I would get rid of that 1/2. So I'll multiply both sides by 2. So 16/9 equals b to the negative second. And then, Brenton, I would think of that as 1 over b squared. And then what? So 16b squared equals 9. B squared equals 9/16. So b equals 3/4. And then don't forget to write your answer. So your answer will be y equals 1/2 times 3/4 to the x. And we never ever combine the 1/2 and the 3/4, right? They stay separate always. Also, in a logistic function, they stay separate. And speaking of logistic function, here we go. We have an initial value of 3/5, the limit to growth of 3, it contains this point. So I don't start with this. What do I start with if it's a logistic function? Y equals a over 1 plus bc to the x. Look at all the given. Is there anything we can get started with?
The limit to growth.
The limit to growth is 3, and that's going to go in where? On top. This number is always the limit to growth. Okay, good. So where do I go from here?
Plug in your initial value.
I'm going to plug in my initial value. I remember that when they tell me the initial value is 3/5, that means 0, 3/5. The initial value is the y-intercept, 0, always. Chuck, you hard time staying awake today? Good. So we're going to plug in 3/5 for y and 0 for x. And what's the beauty of that? This is just 1, right? So now we can cross multiply and distribute. So 3 plus 3b equals 15. So 3b equals 12, and it looks like b equals 4. So now my equation is 3 over 1 plus 4 c to the x. Now I'm going to put in the other point they gave me, which is 3/10 for y, and -2 for c. Cross multiply, so 3 plus 12, equals 30. So 12c to the negative second equals 27. So c to the negative second is going to equal something. That reduces. Let's reduce it. So c to the negative second equals 27 over 12. 9/4.
Should we do 9/4 to square root?
It's going to be the square root of 4/9. And some of you can just get there, and that's awesome. Some of you might want to go through the steps to avoid confusion and potential errors. So here are all the steps that you would go through. But if you can go from here to here, or here to here, that is absolutely fine. C is going to be the square root of 4/9, which is 2/3. So my final answer is y equals 3 over 1 plus 4 times 2/3 to the x. Okay?
That was question 3.
Now we're on to question 3. State the domain, range, and asymptotes. Okay, now in order to do this, this is a no calculator problem, so if you think you're going to type it in, you're wrong. In order to do this, I think we better think back to 2 of our BFFs. Which 2 do you think I should be thinking about? The logarithm and the exponential, right? Because both of these questions involve logarithms. Well, one's a logarithm, one's an exponential. So here's my logarithm function. This is the one I have memorized. And here's my logistic, or my exponential function, the one I have memorized. And there they are. Now, this would be a picture of y equals log x. That's what that is. Notice it has a domain of what? What's its domain? No, domain isn't all reals. Domain is 0 to infinity. What's my range? That's everything. That's all reals. And where's my asymptote? X equals 0. Now, look at problem 3a. What are you doing to this picture? Moving it to the right 1. So the asymptote moves over. The intercept moves over. And the curve moves over. So there you go. There's a picture of it. Right? So what is the domain of this? The purple. X greater than 1, or if you're thinking like a mathematician, you might write it like that, right?
Do you count those?
Yes. What's the range? All real numbers, or if you're thinking like a mathematician, you might write it like that. And what's your asymptote now? X equals 1.
This is Ford.
Yeah.
I'm sorry to bother you. Could I have Brenton Anderson to the front office, please?
Yep.
Thanks.
Hurry up, Brenton. We got work to do. Gotta get dressed. Yeah, I know. Okay, now the next one. This is a picture. This is a picture of y equals 2 to the x. Now you might say, well, Miss Ford, when I memorized it, it was e to the x. Yes, you're right. This is a picture of y equals anything to the x. Anything bigger than 1. Any growth. Anything bigger than 1. Now, where is the asymptote for this picture? Y equals 0 is your asymptote, right? Now, what's going to happen in problem 3b? What are we doing to that picture in 3b? What are we doing to that? Up to. So everything's coming up to. So now the asymptote's going to be up here at y equals 2. And the point's going to be at 0, 3. And it's going to look like that. So what is its domain? All real numbers, or this. This would be the domain for that one. What is its range? 2 to infinity, which we would write like this. And its asymptote is now at y equals 2. Nothing hard about that, right? If you remember your pictures. All right, number 4 is another kind of graphing thing. It says consider y equals 4 to the negative x. It says what's another way to write it? Growth or decay sketch by plotting some points. So we're going to plot some points. That means we're going to set up a t-chart. I can plot whatever points I want, but I want to keep them reasonably small. So I'll just use those points. So what do I get if I plug -2 in for x? I heard somebody say it. 16. What do I get if I plug in -1? 4. How about 0? 1. Anything to the 0 power is 1. 1 would give me 1/4, and 2 would give me, there we go, let's plot them. So -2, 16, oh, it's way the heck up there. -1, 4. 0, 1. Am I surprised by that point, by the way? No, because it's part of every exponential, right? Unless you've moved it. 1 is 1/4, 2 is 1/16. I connect these dots. Look what I've got, a nice little decay. It says, is it growth or decay? Well, obviously, if you graph it first, you can see it is decay. If you didn't graph it first, what's another way of writing this? 1/4 to the x. Can you tell it's decay from that? Your base is less than 1. All right. Okay, number 5. Okay, now this looks like the rest of them are all calculator exercises. The log base 427. We want to evaluate that. We want to figure out what that equals. So what would you do?
The 4 to the x equals 27.
We will rewrite it. Okay. Your calculator does not have a base 4 log button, does it? No. So you got to get rid of that. So what it says, let's say 4 to the x equals 27. And that's just wonderful, except where is your variable? In the exponent. So now we're going to have to log both sides. And somebody earlier today said, well, wait a minute, Mrs. Ford, why do you get rid of the logarithm and then just put it back in? Why do we get rid of the logarithm and put it back in? What logarithm did I get rid of? Base 4. Because base 4 is useless. I can't do anything with it. What logarithm did I put in? Base 10, which I can type in, right? So out comes the exponent. So what are you going to end up typing into your calculator? Log 27 divided by log 4. So you should get x equal to about 2.377. Right? All right, here we go, number 6. Okay, it's a word problem and no formula is given. So that means you have to decide what formula to use. All right, so is it going to be one of the ones that are listed on the paper here, or is it going to be one of your memorized ones? One of your memorized ones. Is it going to be PERT or the other one? The other one. We are compounded quarterly, so it's going to be the other one. Alright, so what am I going to put in where? It says compounded quarterly. This is my compound interest formula. So what am I putting in where? 4 equals 1. Now, do I have to use 4 and 1? No. I can use anything I want as long as I'm ending up with 4 times what I started with. Right, Dylan, what did you do? I have to end up with 4 times what I started with. So So I could start with 10 and end with 40, right? I can look at whoever I want when I'm reprimanding Dylan. Yep. So my interest rate is 0.024 divided by what? 4, because I'm compounding quarterly. And I want to know how long it's going to take. So my variable is t, right? How many years is it going to take? Step 1, I know I'm going to need logarithms. Look where your variable is. That means you're going to need logarithms, but not yet. What do you have to do first? Divide by 1. Now it is just 1, but get in the habit of dividing. And that probably divides nicely. So is that 1.006 to the 4t? Now I only want you doing that if it divides nicely. If it doesn't, just leave it be. You can type it in later. But it divides nicely, so there you go. We want to solve for t, so at this point we will log both sides. Could you, if you wanted to, ln both sides? Yeah, but there's no benefit to that, but it's fine. It will give you the same answer. Why did you do it? To bring down the 4t. That's why you did it. You have to get that 4t out of exponent mode. Now we're going to divide. When we divide, we're going to take the log of 4 and we're going to divide it by 4 and the log of 1.006. Since there are 2 things down there, be sure that when you hit divide, you have parentheses. So the log of 4 divided by the log of, or not the log of, divided by parentheses 4 log 1.006. I think I got that all right. Did you get about 57.94 years?
Mrs. Ford, why did you bring the 4 down with it when you were dividing?
Because I'm solving for t. I got to get rid of everything that's not a t. Find the interest rate necessary to grow 567 into 987 in 15 years if interest is compounded monthly. All right, so again, there's no formula given, so you need to come up with one. Is it going to be one of the ones on the page or one of your memorized ones? Memorized. Is it the PERT one or this one? Compounded monthly. I'm looking at problem 7, are you? This is the one I'm going to use. So I want to end up with 987 if I start with 567. And I don't know the interest rate, but I know it's compounded monthly for 15 years. Now, pay attention. Where is your variable? Is it an exponent this time? No. So you will not be using logarithms. All right? What are we going to do? Divide by 567. That does not go in evenly, so just leave it as a fraction. And I'm going to go ahead and 12 times 15, is that 180? Yeah, I'm going to go ahead and do that. Make it a little easier on myself. Now, I'm not using logarithms. Don't even think about it. Okay? Back in the old days, before calculators, we did. That's what we had to do. We had to take the logarithm of both sides. Took forever. You got a calculator. Let's use it. How can we proceed with this? We're going to take the 180th root of both sides. Because when you take the 180th root of both sides, it's going to cancel out the 180th power and leave you with just 1 plus r over 12. Now on the calculator, you can take the 180th root, but I bet I've told you already, I never do that. I raise to the 1 over 180 power. It's just easier for me. I don't have to search for that button. I have it. So 987 divided by 567, then raised to the parentheses 1 divided by 180. Did you get 1.00308 something? Okay, now that's this. That is not your answer. That's this. So you're going to subtract 1 from that, and then multiply by 12. So the interest rate is about 3.7%. All right, number 8. What is the rate of growth for a strain of bacteria that grows from 789 to 3210 in 16 hours? Okay, no formula given. So is it one on the page or one of your memorized ones? It's one of your memorized ones. And which one is it? PERT, because problem number 8 doesn't have anything to do with money, does it? And of the 4 formulas, they all are money formulas except PERT. So if it's not money, you're using PERT. So here we go. What are we trying to do? We're going to end up with 3210, starting with 789 in 16 hours. Here we go. Your variable is up there in the exponent again, so you're going to be using logarithms, but not until you divide. So 3210 divided by 789. Always divide first, right? Now we'll ln both sides. Have an e in our problem, so it's beneficial to do that. So we have ln 3210 over 789 equals what? What's this equal over here? Just 16r. So r is going to equal this over 16. So ln 3210 divided by 789 divided by 16. My interest rate is about 8.77%. Or it wasn't interest rate, it was growth rate, wasn't it? So the growth rate of this bacteria is about 8.77%. Right? Okay, number 9. This one's a little bit different. It's not a word problem. I think we did one like this, but I can't remember. Our job is to figure this out. Okay, so first of all, there's a logarithm and a radical. They don't mix. So what are you going to do? You're going to write that exponent, or that radical, as a 1/3 exponent. And then what are you going to do with it? What do you do when you take the logarithm of something to a power? What happens to the power? It comes out in front. So I'm going to write that as 1/3 log x, log base x, 25x squared. Can that be broken down at all? You can break that down. Think of the prime factorization. You can break that down. You can think of that as 5 times 5 times x squared. You could even make it xx if you wanted. You don't need to, but you could. Now, see how these are being multiplied? what if I decided to expand that? I could expand that and make it log base x of 5 plus log base x of 5 plus log base x of x squared. Now, a while ago, we were putting equations together. Remember that? I'm doing the opposite of that here. So if these are all being multiplied, I can pull it apart as an addition. Now, why in the world would I do that? Well, look at the given. What was the given? They gave me this value, right? What's the log base x of 5? 0.123. So that's 0.123. What's this? Another 0.123. What's this? No. That's 2. The log base x of x squared is 2. So I have these 3 numbers all added up and then multiplied by a third. And that is the answer to the question. So 0.123 plus 0.123 plus 2 divided by 3. So did you get about 0.7487? Now, what I'd like to do, and I know we got a little bit more, but we've actually already done a couple problems. Let me give you another example of this one. So you can just do it over to the side, or you can do it right there on that paper. Let's just practice another example using the same given that they gave you. So the given was the log base x of 5 and the log base x of 2. That was the given. Okay, so suppose I said, let's find the log base x of 125x over 4. Okay, now keep in mind that is the given. So 125 and 4 weren't given. So what did I do over here with my 25? I broke it down into the given. So how shall we break this guy apart?
Minus log.
Okay, so step 1 might be this. Is that a good step 1? Why is it a minus? Because it was a division.
Can you break that down?
Oh, we can break it down more. Oh, yeah, we can. What's 125? 5 times 5 times 5 times x. So can we think of that as the log base x of 5 plus the log base x of 5 plus the log base x of 5 plus the log base x of x? Because 125 is 5 times 5 times 5 times x.
Do you still keep the 4 in there?
Well, I'm not done with now. I still have to deal with this now. Minus what? What am I going to do with the log base x of 4?
X of 2.
It's 2 times 2. So that will be the log base x of 2 plus the log base x of 2. Now notice it's in parentheses because I am going to have to subtract that whole thing, right? So what's this? 0.123, 0.123, 0.123, what's this? 1 minus, in parentheses, 0.012 plus 0.012. And then I could multiply all that together, or add it all together, whatever, and come up with the answer. So what's the key to doing those problems? Taking it apart, breaking it down till you get the numbers that they gave you. right? Problem 10, we don't have time to do the whole thing, it's a 4-parter, we already did one like it. Are there any of those questions I can answer without doing any work in problem 10? Which of those 4 questions in problem 10 can I do without doing any work? A. And the answer to A would be 420, if that's a 420, which I haven't, I'm reading it, but it looks like 420. Because we know the maximum is the numerator. All right, I do not see you tomorrow, but I see you on Thursday, right? So we will review for, oh wait, did I see them Friday also?
Yeah.
So I have 2 more reviews